Alright, today we're going to find the length of the curve defined by y equals 1 plus 6x to the 3 halves from 0 to 1. So limits are from 0 to 1. I posted this problem back a while ago and it's really messy, so I'm going to try to explain it as simple as possible. The first thing is we want to know what we're doing. We're trying to find the length of this curve. And this curve, oh, that's horrible. Pretend that's a straight line. This curve, I don't know, it's going to look something like, maybe something like that. Well, that's horrible, but something like that, maybe, I don't know. And of course, we want to find the length of this thing. What a beautiful L. So basically, when you do this, you have to use this formula that's called the arc length. And this formula, it says that if the equation is in y equals fx, then you can use this equation that says from the limits a to b, this is the arc length formula. I don't know why I wrote the L like that, don't judge me. 1 plus dy over dx squared dx. This is the formula. So we look and we can see that we have y equals fx and we have it in this form. So we can go ahead and we can use this formula. We also have the limits 0 to 1. So this is our a and this is our b. A and b. So the first thing we know is that we need to get this dy over dx, which is the same thing as saying, I want to say this right, it's the same thing as saying differentiate y with respect to x. So essentially we're going to take y prime. So we know that, sorry about that, get that fixed. Okay. We know that y prime y prime is going to equal, let's see, 3 half, 9x 1 half. That's our y prime. Now remember, this is kind of confusing, that dy dx is the same thing as saying y prime. So dy dx equals y prime. So similarly, if dy dx equals 9x 1 half. So there we have it. We have our dy dx. So go ahead and get the screen's getting messy, sorry. So now we're going to go ahead and we're going to use our formula. So remember, our formula says from a to b square root of 1 plus dy dx squared dx. Now we're going to plug that in and we're going to see that, well, remember what our a was, they told us. So we know our a and b is from the limits of 0 to 1. And we know our dy dx. Remember, we solved that. We said that y equals 1 plus 6 Probably shouldn't have erased all that if I was just going to rewrite it. Which equals 9x 1/2, and we said that y prime equals dy over dx. So now we know what that is. So we're going to have 9x 1/2 squared dx. So let's simplify a little more. We're going to have the integral from 0 to 1, square root of 1 plus, now remember 9 squared, remember, wow, 9 squared is 81, and remember, this always trips up people. Whenever you're squaring exponents, you multiply them. So x to the 1/2 squared is 1/2 times 2. So it's going to be x 2 over 2, which equals x1 x. So we're going to have 1 plus 81x dx, all under the square root. Alright, now we're going to look at this, and there isn't much we can do with this nasty number under the radical. So what we want to do is a u substitution. I want to get rid of this so we have some room to write all this mess out. So we're going to do this u substitution. So the way we're going to do this is we're going to let u, well, first we're going to have to do that. Okay, we're going to let u equal 1 plus 81x. That is going to be our u. So then du, which means the derivative of u, is just going to be 81 dx, because it's the derivative. So now we see that du equals 81 dx, or so basically du equals 81, or du over 81 equals dx. The reason why this is important is because this is going to go here. We had to find that. Because remember, this dx was not included in this u substitution. So now we're going to rewrite, and we're going to update our limits. So we have to set up our new integral. And remember that since we made a u substitution, when you make a u substitution, you always have to update the limits. Unless you're going to unwrap the original substitution for u, which is ugly, and I wouldn't do that. So instead of making things complex, we're just going to update the limits. And here's how we do that. Remember, we let u equal 1 plus 81x. So all we have to do is we simply plug in our old limits into u to get our new limits. So u of x 1 plus 81x. So we plug in our old limits. So first we'll have u of 0, which equals 1 plus 81 times 0. So u of 0 equals 1. And that's going to be our lower limit. That's the symbol I'm going to use for lower limit. And then the other number we had was a 1. So for our limit, we'll plug in 1. And we'll get 1 plus 81 times 1, which is going to equal 82. So 82 will be our max limit. So now we're going to rewrite this, and we're going to write it with our new limits, because now remember we have 1 and 82. So now a is going to equal 1, and b is going to equal 82 because we updated our limits. They're no longer 0 and 1. So remember, before 0 was a. We plugged in 0, we got 1. So now that's our new a. And before 1 was b. We plugged in 1 here, we got 82. Now that's our new b. So we're going to have 1 to 82 as the limits. And then we're going to have, well, remember we made this u. So we're going to have u here. And u is under the radical. And remember, anything under the radical, you have x square root of the radical. That's the same as x to the 1/2. I know this stuff is real trivial, but messes a lot of people up. Okay, so literally the hardest part in Calculus 2 is the algebra, is what I always remember my teacher saying. So this is going to be u to the 1/2. And of course, this dx, well, remember that this is u now. So this this dx, remember, we said is equal to du over 81. So that means that this is going to be du over 81 because this used to be dx. We just replaced it and showed what dx equals because we need it in terms of u because we're taking the integral of u. So we have to have a du here. Now, we look at this, it's ugly, okay? So we don't like it. So what we can do is, since du over 81 is the same as 1 over 81, we can, oh, well, that's interesting. Okay, don't want stars. We can just change this to du and pull that 1 over 81 out front. Now, this makes things look better. So now, we want to solve this integral. So, we're going to have 1 over 81 times, now remember, we're going to take the integral, so we're going to add 1 above. So we're going to add 1 here in the exponent. So we're going to get u to the 3/2. 1/2 plus 1 is 3/2. And then we're going to flip. We're going to take the reciprocal of this new number, and that is going to go here in the coefficient. So then we need to remember that we have our new limits. The lower limit being 1, the maximum limit being 82. Now we need to find the length, take the maximum limit minus the lower limit. Maximum, lower. So we're going to have to plug in each number. So let's do the first one. So the first one, this is going to get kind of messy here. Let's see. The first one's going to be 1 over 81 times, well, let's do this. 1 over 81 times 2/3, plug in the maximum, 82 3/2. So that's with the maximum number. And this is going to be, let's see, 80 times 3 is 240, so it's going to be 2 over 243, 243. Open my tab, make sure that's right. Yes, that's right. And that's going to be times square root of 82 cubed. So, the reason, oh, let me scroll down here and make sure I'm not messing this up here. 1/3, okay, yes. So, then, what we're going to do is, we're going to remember that 82 3/2 is the same as 82 square root of 82 raised to the 3. I know that messes with some people. So what we're going to do now is we've took the maximum limit. Now let's take the lower limit. So here's our maximum limit. Let's do this so we can point it out. Now we're going to take the lower limit, and what we're going to get is 1 over 81 times 2/3 1 3/2. Sorry, I should have drew a line here. And the lower limit, which of course is going to equal 2 over 243, because the square root of 1 is just 1, and then 1 cubed is 1. Everybody see that? Because 1 is the same thing as square root of 1, which is just 1, cubed, which is just 1. So we're going to have 2 over 243. So now we're going to take the maximum, which is this, minus the lower, and we're going to get 2 over 243 times square root of 82, 3 minus 2 over 243. Now, we're basically done almost. The book and the solution, they split this 82, so that's how I'm going to write the final answer. And the final answer, we're just going to factor out a 2 over 243. So you're going to have a 2 over 243 and times. Now here, they split it up in the book as a solution. I don't know why they do it, but they do it. But you can leave it as 82 cubed. Or square root of 82 cubed. But they take 82 and split it up. And they get 82 times square root of 82. And then, of course, 2 times negative 1 is 2 over 243. Now, if this is screwing with you, just remember that square root of 82, well, I'm writing all sideways, let's fix this. Just remember that square root of 82 is just equal to 82 1/2 cubed. And remember, when you square exponents, you multiply them. So remember that 1/2 times 3 is just 3/2. So then you have 82 to the 3/2. Well, remember that 82 to the 3/2 we just deduced is square root of 82 raised to the 3rd. So remember that this 82 times square root of 82 is the same thing as saying 82 to the 1 times 82 to the 1/2. And when you're multiplying these, you add the exponents. So that is just going to be equal to 82 to the 3/2. So, see, they're equivalent. So, the point I'm trying to make here is they switch all over the place. They make it overly complicated. But basically, 82 square root of 82 is, of course, the exact same thing as 82 3/2. Now, that's the answer right here is the answer. And if you want to actually get the decimal approximation of the length between those limits. I did it, and I believe it is, I've got on here, L is equal to 6.103222895159. That's if you know, really just want to go all out. And also have a written explanation on Slader.com, and I will post that link below if this video was absolutely horrible and sucked. So thanks for watching. Hope I helped bring some clarity.